Welcome back, ladies and gentlemen. I'm just going to do a quick video going through all the problems in your practice quiz for this upcoming quiz on factoring and square roots. So kind of bear with me. We're just going to walk through these problems and feel free to pause as we go if you need any questions. First problem here, 6x squared minus 28x plus 30 equals 0. Okay, I'm looking for a GCF first. Everything can be divided by 2. Okay, sorry, it's going to focus real quick. So if I divide everything. Okay, so now I have no more GCF, so what I have to do is I'm going to do my AC on top and my B down low. So 3 times 15 gives me 45, and then down low I'm looking at negative 14. All of my factors of 45, 1 and 45, 3 and 15, 5 and 9, which of them adds up to negative 14? Well, you're looking at negative 5, negative 9. Okay, so just like we talked about in class, you bring down your first and your last. 3x squared plus 15 equals 0. I'm going to bring down these two values, minus 5x, minus 9x. Okay, it doesn't matter which order I put them in. And I'm going to put parentheses on my first 2 and my second 2. What factor can I take out of 3x squared minus 5x? Just an x. I'm left with 3x minus 5 inside the parentheses. And what can I take out of negative 9x plus 15? I can take out a negative 3, which leaves me with a 3x minus 5. Okay, keeping in mind that you always want this to be positive. These are the same. I know I'm doing this right. 3x minus 5, cover them up. Okay, x minus 3 is left over. Boom, this gets you 8 points right here. Then I can set each of these equal to 0. This one's easy. I add the 3 over. Boom, x equals 3. And then here I can add the 5 over. 3x equals 5. Divide x equals 5 thirds. Okay, very cool. Okay, number 2. So as we mentioned in class, you have to get everything equal to 0. So I'm going to go ahead and subtract 6x squared over. I'm going to add 3x over. I'm going to subtract 2 over. This gives me 4x squared. Negative 8x plus 3x is minus 5x. 3 minus 2 is plus 1. And then when I do all of these over here, I'm going to end up getting 0. So now there's no more GCF I can take out. So I'm doing my A, C, B. 4 times 1 is 4, A and C. And my B is negative 5. All right. And from there, all right, so now I'm thinking of numbers that can multiply, give me 4. 1 and 4, 2 and 2, add to negative 5. Negative 1, negative 4. Okay, same idea. Factoring is just a process. Bring down my 4x squared, bring down the plus 1. In the middle I can put these values, negative 1x, negative 4x, equals 0. Okay, parentheses around the first 2, parentheses around the second 2. What can I take out of 4x squared minus x? Just an x. What can I take out of negative 4x plus 1? Now, there's no common number, no common x, so it's just going to be a negative 1. 4x minus 1, good. Okay. These are the same. I know I'm doing it right. 4x minus 1, cover them up. What am I left with? Just x minus 1. Okay. That's 8 points right there. Then I can set each of these equal to 0. X equals 1 here. 4x equals 1. X equals 1/4. Okay? Make sure you're leaving your answers as a fraction. Very good. Okay. Now we're getting into our perfect squares, okay? Square roots. So if you're looking at this, again, what you could do is on your graphing calculator, if I go to y equals, and if I type in x squared, and I hit second graph, this pulls up all of my perfect squares over here that I can use as I'm going through this, okay? So for 128, the one that I'm looking for, the highest perfect square over here that works, is 64. 64 can go into it twice. Okay, now, what's the square root of 64? Well, just 8. What's square root of 2? Well, I can't break that down, so it stays square root of 2. Okay? So this is going to be the trickiest part for you guys. When you break down a perfect square, it becomes a regular number. If it's not a perfect square, it stays in the square root. Okay? So for 18, what perfect square can go in 18? Well, I'm using my chart over here. start with the next smallest perfect square, so 16. 16 cannot evenly go into 18, okay? So for example, 18 divided by 16 doesn't work. Then you go to your next smallest one. If you do it this way, it tells you those are the two numbers that I need under the square root. So root 9 times root 2. The square root of 9 is 3. The square root of 2 is a square root of 2. Alright? And again, if you guys are curious, you can. I come here and go square root of 18. Oops. Okay, so that's 4.24. But then my final answer was 3 root 2. See how it's the same thing? I know I'm right. Okay, it's a good, quick, easy self-check. Number 3, square root of 64. 8. Done. Okay, it's perfect square. Moving on. Number 4, what perfect square could go into 48? Well, I can play with it a little bit. Alright, this one's going to be 16 times root 3. The square root of 16 is 4 root 3. If you wanted to, which you guys could also do, I explained this in class the other day, you can break it down with smaller square roots. 4 can go into 48 12 times. Okay, the square root of 4 is 2, but you have to break this down again. This becomes root 4 times root 3. The square root of 4 is 2. 2 times 2 is 4. Me personally, I would always do it this way. Like, don't do both, just pick one. That's supposed to be an arrow, a really bad arrow. Do this way, right? It makes your life super easy, okay? Cool. All right. Number 5, 3 root 2 times root 2. So, what I've got here is, you are allowed to multiply numbers under the square root together. So, root 2 times root 2 gives me square root of 4. Awesome. What is the square root of 4? Well, it's just 2. So now I've got 3 times 2. Oh, now they're both outside the radicand. So I can multiply them together. 6. Okay. Cool. Number 6, 3 and 8. Now, again, different ways to do this. Since they're both square roots and you're multiplying, let's multiply them together and get 24. Okay, what perfect square can go in 24? Well, 4 can. 6 times. Okay. What's the square root of 4? 2. Sweet. Okay, and again, you can check all of these via calculator if you would like to. Alright. Now, number 7. Root 10 times root 5. Again, multiplying. So if I connect them together, I get root 50. Okay. Square root of 50. What perfect square can go into 50 evenly? Well, we're looking at 25. You can go in twice. Square root of 25 is 5. Boom. Okay. Hopefully you guys are noticing a pattern here. 8, I've got a regular 3 that's going to stay there, but underneath it I've got 3 times 27, which if I do a little bit of multiplication will give me 81. Alright, well I'm looking to break this down. The perfect square that can go in 81, well actually it just breaks down to become 9. So 3 times 9, 27. You're all set. Okay. Cool. Okay, our last 3 here with the fractions. So, you can break this up to be the square root of 4 over the square root of 25. Now, that's good. Take a look up top. The square root of 4 is 2. The square root of 25 is 5. I'm totally good. Done. I'm all set. Alright? The thing I'm worried about is there a square root in my denominator? When you finish your problem, there should never be a square root in your denominator. Okay? Here, root 1 over root 81. What's the square root of 1? 1. What's the square root of 81? 9. 1/9. Do I have a square root down there? No. Okay, we're done there. Now, here is where I run into a little bit of difficulty. I have a square root of 7 up top. That's fine. I can't break that down, but I really don't care about it. This I do. You cannot have a square root in your denominator. So we have to rationalize denominator. Okay? Which means I have to multiply top and bottom by square root of 2. Keep this in mind, guys. What is the square root of 2 over square root of 2? It's still just 1. Okay? I'm not changing the value of the problem, I'm changing the way it looks. My numerators, root 7 times root 2 is root 14. my denominators, root 2 times root 2, is square root of 4. Well, that's cool because what is the square root of 4? 2. So I have root 14 over 2. Can I reduce those? No. Okay. The square root of 14 is not 14. All right. It's between root 9 and root 16, so it's between 3 and 4. You're done. That's it. That's all she wrote. Okay. So as always, keep up the good work. All right. Hopefully this stuff is doing okay for you. If you have any questions, please feel free to ask. And as always, keep up the good work and good luck. We're all counting on you.